Hello, my name is Sanjiv and this is my colleague Mervin James. Today we'll be presenting a proposal for optimal vaccine distribution in the pandemic era. Vaccine distribution is a complex challenge that pharmaceutical companies face each year. In the 2018 to 19 season, manufacturers were tasked with distributing over 169 million doses of the influenza vaccine. With the advent of the coronavirus, the challenge of vaccine distribution will only be compounded. For example, the company Moderna expects to manufacture over a billion doses of the COVID vaccine by 2021. Some obstacles to distribution include transport costs, local and federal vaccine regulations, technological requirements, racial and ethnic disparities, and communication efforts.
We propose to use data such as past pandemic models, the locations of cold storage facilities, available supply, the known prevalence of certain risk factors, and established transport patterns to determine optimal routes of vaccine distribution in a predetermined region. We would also need to account for defective vaccine percentages and federal regulations. Here is an overview of some existing machine learning and predictive analytics tools used by companies to model supply chains. To handle epidemic modeling and prediction, we could use SymPy, a discrete event simulator for Python and Cython. There are also too many factors to accurately simulate epidemics, so we would use an agent-based model. What this means is that we would simulate a randomized population with different subsegments that have unique characteristics. Then every individual would interact with each other, generating a model. Using this, we could determine a pandemic spread over time. Pandas, an industry standard data science Python tool, can assist in analysis and modeling. For supply chain management, we would use Pulp, a Python linear program optimization modeler. This tool can determine mathematical relationships and develop optimal outcomes using given constraints, such as allocating supplies to resource-deprived locations. In our case, these resources are specific cold storage facilities. Using these and other libraries, we can determine where resources are most needed and the best way to distribute vaccines to these locations.
There are certainly a number of obstacles in this project. To start, we are novices in data modeling. We have some Python data manipulation experience, but we would need to learn these specific libraries. There are also a host of factors which we would need to accumulate data points for. These include determining where companies like McKesson prefer to transport their vaccines. We would also have to be wary of racial bias that our program may create. The proposal is sure to require the help of experienced Rutgers professors like Dr. Halkitis, a current dean and professor of biostatistics at the School of Public Health, or Dr. Hoover, who is a professor at the Institute of Health, Healthcare Policy, and Aging Research. These professors have experience in pathogens, risk factors, and modeling of diseases in large data sets.
Thank you for your time, and we hope we can make this project a reality so that we can, together, leave this pandemic quickly behind.